So question 3 contained four expressions that they were monomials, and they all involved exponents, negative exponents, perhaps some parentheses with exponents, and maybe even some division. And you're just asked to rewrite these in so they're simplified completely. Simplification is the art of reducing the number of operations needed to evaluate an expression. And I think as you watch this happen, you'll see that, yeah, we're significantly reducing the number of operations that are needed, required to evaluate this particular expression. And for historical reasons and for just aesthetic reasons, also uh, avoid negative exponents, right? So your answer should only contain positive exponents. Um, oh, now I'm recording. I think I'm going to take a slightly different tack today. I'm going to look at this, and I want to see each one of these as individual products. So it's 2 times something, right? There's no multiplication there's no parentheses here. So it's 2 times an x to the negative second. And then it's times a y to the negative fourth. And then a times a 4. And then times an x to the fourth. And then times a y to the negative ninth. So if I look at these, I understand that there's definitely a numerator and a denominator. In fact, I'll write that in red. And there are several things that are going to make it into the numerator and several things that are going to go to the denominator. So when I look at this 2, right, that's going to go into my numerator. The next two have negative exponents, and I can go through the justification of why that's the case, but both of those factors of x and factors of y are going to be in the denominator of my answer. So I'll put those in blue boxes. Those are going to be in the denominators. This next one's going to be in the numerator. This is going to be in the numerator. And then again, with this negative exponents, these are going to relocate to the denominator. So when I try and look at it this way in this chunk, right, I can see things that are a little bit different. So in my numerator, I've got, I've got a 2 times 4, and then I've got a times x to the fourth power. So my numerator looks like it consists of 8x to the fourth. In my denominator, there are 2 factors of x, so I've got an x squared, and then I've got 4 factors of y and 9 additional factors of y. So there's a total of 13 factors of y that live in my denominator. So we can rewrite this. All right, it's 8x to the fourth over x squared y to the 13th. And yeah, if you're saying it, you're correct. There's definitely a giant one living here. And I'm just going to focus on the x's. For example, in my numerator, I'll rewrite this x to the fourth as x squared. And in my denominator, you can see there's an x squared. So the only reason why I wrote it that way is so that I can very clearly see that there are 2 factors of x that live in the denominator, and there's 4 factors that live in the numerator, and I can pair up or group together 2 of the factors from the numerator and the 2 in the denominator and create a giant 1. When I do that, I'm left with just 2 factors of x in the numerator. So my numerator is 8 times x squared, and my denominator is y to the 13th power. So this is the answer that I would settle on for part A. Let's take a look at part B, which is way over here. Here we go. So a little bit different this time. This time I have some parentheses, and this is going to be interesting how this works out. So I guess part of it is I can move things down into the numerator denominators first. So if I look at this, I can see this numerator this is to the positive third power. So I'm just going to rewrite this as 2y to the negative second. We'll have to deal with that. But this is to the third power positive. And then below I'm going to write an 8x, and then that's to the negative second power. And you can also see that the numerator contains this y to the 7th as well. So I just made a big mistake, right? When I moved these factors of 8x, this had to become a positive exponent. So it's now positive second. That's my reason for moving it down there. So if I take a look at this now, there's already some benefits here. The denominator, it's an 8x times an 8x, so 8x, which is 8 times 8, 64x squared. So in my denominator, that 8x to the second power is 64x getting squared. There's still a y to the 7th power. Let me put that y to the 7th power in the numerator. And then also in the numerator, let's deal with this. There are three factors of this 2y to the negative second. So I'm going to go ahead and expand that out. 2y to the negative second times 2y to the negative second times 2y to the negative second. So in doing this, it's a little tedious, but I can see now that I have three factors of 2 that are all being raised to the first power, right? It's a 2 times a 2 times a 2. 2 times 2 is 4, times 2 is 8. So in the numerator, I have this 8 and then y to the 7th. And you guessed it, I'm moving those y's to the negative second power down into my denominator. And in fact, when I look at it, there's 1, 2, 3, 4, 5, 6 of them. So I'm going to rewrite this as 64 x squared and then y to the 6th power. We're a lot closer. There's a couple more things that we can do, and we should do them. One of them is this denominator is 8 times 8, right? 64 is 8 times 8, and I can see that there's an 8 in the numerator. And if I was to look at that in expanded notation, right, 8 times 8, there's no doubt at all that this is just going to be 1 over 8. So 8 over 64 is the same thing as 1 over 8. So I think I'll do that. I'm going to go ahead and put just the one factor of 8 in my denominator. And I've got this x squared. The other thing that I have is a y to the 7th over y to the 6th power. If I look at that y to the 7th power, there's 7 factors of y flying across the numerator, and there's 6 factors of y in the denominator. I don't think we need to do this at this point. 3, 4, 5, 6, 7, but I'll just write them out anyways. So there's my 7 factors, 1, 2, 3, 4, 5, 6, 7 factors of y over 1, 2, 3, 4, 5, 6 factors of y. And if I take 6 from the top and use the 6 down in the denominator, I end up with a single factor of y in my numerator. So the final answer that I settle on is this. It's so compact. It's just perfect looking, right? It's just y over 8x squared. Y over 8x squared. And that literally would take so many fewer keystrokes on a calculator to evaluate that again and again. Or if this lived in a for loop in a computer program, it would be a lot more efficient to evaluate this expression repeatedly as opposed to this one. Computers don't care. They could definitely evaluate that top expression just fine, but wherever we can get some computational savings, it's worth thinking about. So definitely we reduce the number of operations needed to evaluate that. So that's part B. Let's move on to part C, A, B, C. So when I'm looking at this, I definitely see this as a chunk, right? It's 4x, and that's getting raised to the negative second power. So I'm just going to go ahead and bring those up to the numerator. So my numerator had a 4x squared, and I'm going to have join it another in parentheses 4x squared. So that's a little different, right? Those are two different things. This first one is just a 4 and an x and a square, but the other one is a 4x, 4x, right? There's two 4x's, 4x, 4x. And when I multiply that, 4 times 4, I get 16. So this is 16x squared. And I have to say, I have to be honest, I'm not sure what that is. 4 times 16. So when I multiply, oh yeah, I should have known that, especially from the last problem. 4 times 16 is 64. So when I look at it, 4 times 4 times 4 times 4 is 64. And then I've got 2 factors of x, and then 2 more factors of x. So this is times x to the 4th power. So my answer here is 64x to the 4th. And question D. Similar, right? I think I set this problem up this because I wanted you to focus on the difference between things being squared in parentheses and things not being squared. So this, you can see my numerator is just going to have a 1 left over because I'm going to take this 3x in parentheses to the second power, and I'm going to migrate it to my denominator. So now this is a 3x times a 3x. So if I was to write this out in expanded form, it would literally be 3x times 3x times 3x. I could just go ahead and square the 3x, right? 3x times 3x is 9x squared. And I'm going to be multiplying that by an additional 3x. Well, 3 times 9 is 27, and x times x squared is x to the third power. So this whole thing is 1 over 27x to the third power. So that's the end of question 3. That was part D.